Kia ora koutou. This video is going to go through a bunch of old exam questions looking at features of graphs. So the questions are going to look like this one here from 2019, where you get given a graph and it's a weird kind of graph of some function, and you have to talk about things like continuity and differentiability. So what I want to go through here is first a little checklist that you can use to make sure you've got the hang of all of these ideas. And then I'm going to get into the questions. But just really quickly, I'm going to do some drawing on this page before we actually look at questions. So most of the ideas we're seeing in here are at a very intuitive level at level 3. And then as you go further in maths, you can formalize them and get into a lot more depth. But at this stage, what we mean by each of these things goes like this. So continuity means when I'm drawing the curve, do I have to lift the pen? So a graph can have weird bits and still be continuous, right? So you can see that there's funny stuff going on here and here. But continuity is just saying, are there any jumps in the function? So that's what continuity is going to be about. The next idea is about differentiability, which is a little bit stronger than continuity, and that's the idea of smoothness. So if I've got this curve, I can find the gradient anywhere along that curve, right, by the idea that we had back in level 2, that it's the limit as we take a chord and we bring it closer and closer to the point. So for a function to be differentiable, oops, we just lost the function, there we go, then that limit has to be the same on both sides. And what that turns into graphically is a condition that we've got a smooth curve. So the one that I've drawn there is differentiable everywhere. This is a bit dodgy. This is looking a little bit like a kink, but it's not. So that curve is smooth, right? It's differentiable everywhere. Here are a couple of examples of where a curve is not differentiable everywhere. Right, so you can see that at this point here, if you are going from this side, the gradient is, I don't know, 0 or slightly negative. But if you're coming at it from this side, the gradient is something else. So it's not smooth. So anywhere where there's like a pointy bit, it's not differentiable. Okay, but it is continuous. Then the next kind of thing we're going to see are gaps in the curve. So this is where the idea of a limit comes in. Is the graph heading to the same place from above and below? And in this case, this hole here might mean that the point of the function is way up here. So there's a jump, right? There's some strange value up here. So this might be f, say this x value is 5. Then f of 5 comes from the big black dot. But the limit of the function as we're going towards 5 is this thing here, whether I'm going from above or below. So in this case, the limit is whatever that value there is. You'll see how this works when we get into the actual questions, right? Other things to watch out for is that if we've got a situation like, let's just do some more bad drawing. Suppose that we've got a function that looks like this, and then it's got a big gaping hole and it goes like that. If we look from going from below to this value and going from above, then pretty obviously we're not heading to the same value, right? That's why we've got this big amount of space. So that means that the limit is not defined, right? Because the graph has to be heading to the same place from above and below. Okay, so the next idea that we come to is concavity and points of inflection. And we know this from back in level 2, right? So if we've got a parabola like this, then we say that it is concave down. And what that means is that we're talking about the second derivative. So if it's concave down, that means that as I go further, you can see what's happening to the gradient. So if you get stuck on this in the exam, this is what's happening to the gradient. And the gradient is getting lower and lower. So that means that the rate of change of the gradient is negative. And that fits with my test for a maximum, right? So that's concave down. And concave up is the other way around. And that's where the second derivative is positive. And a point of inflection, when you're looking at the graph, is the point where that concavity changes. So here, the point of inflection is going to be about here. The best way to see that is to take your hand and cover up the side on either side and see if it looks like concave down on one side and concave up on the other side. Two last things, just be careful with horizontal lines, the gradient 0, and vertical lines, the gradient's undefined. So now I've spent 5 minutes just talking without an exam question. I promise I'm going to do some exam questions now. Last thing, this video is brought to you by a very sad dog who's watching me make this video, and she might cause problems. So we'll see how many questions I get through before I get interrupted. Okay, so 2019 had this function, and this was the first year that these questions started being at achieved level instead of merit level. So we've just got 3 things to work out here. The first thing is we have to find all of the places, all of the values of x where the gradient is 0. So just work carefully from one side to the next. Is the gradient 0 here? No, definitely not. 0 here? No, it's not. Now notice here at that place, we can see already that we've got a kink or a corner in the graph. So the gradient's not defined there, right? But they didn't ask us that. The gradient is not 0 here, but finally we can see that the gradient is 0 here, right? So the first place to write down is x is equal to 2. Secondly, I've got this horizontal line here. So for x is strictly greater than 4, I've got the gradient equal to 0. Now it's strictly greater than 4 because at the point where x is 4, the gradient's not defined because it's not the rise over run, basically, as we get closer and closer to that point, is not the same from both sides. Okay, so I think I'm going to check the answers in a minute, but they are the 2 places where the gradient is 0. Where is the function not differentiable? Right, so we're looking for places where it's not smooth. So here's the first one, here's the second one where there's a jump, and here's the third one. Right, so it's not differentiable when x is equal to -2, 1, and 4. So just think about what I'm trying to look at is the change in y over the change in x. As we shrink that smaller and smaller, is that the same from both sides? Okay. Lastly, what is the value of the limit as x goes to 1 of the function? Let's look at what's happening from below. So as we head towards x equals 1 from below, we're heading towards 3. As we head to 1 from above, we're heading towards 4. Because those two numbers are different, the limit doesn't exist. So let's quickly mark that question and see if we got it right. Okay, perfect. And you had to get 2 of those correct to get an achieved code. In 2018, though, it was a merit question. Here's the function, and we've got to do a wee bit more work. So if you got a certain number right, you got achieved, and then if you got most of them right, you got merit. First of all, what is the value of f of 1? So when x is 1, what is the value of the function? Well, we can see that we've got this big dot here. That's the value of the function, and that is 5. Right? This open circle means that we've got a horizontal line until we get up to x equals 1, but then it jumps up to here. Right, for what values of x does the function not have a limit? Let's look at all the weird places in this graph. So here, the graph is heading to the same place from above and below, so it does have a limit there. It doesn't have a limit here because it's not going to the same place from above and below, and it doesn't have a limit here. But again here, it does have a limit because it's going towards 5 from above and below. So tricky places here, so places where it doesn't have a limit are x equals -3 and x equals 1. Remember, we're looking at the x value, not the y value. Right, next questions. Where is the gradient strictly positive? Be careful with your endpoints, right? So the gradient strictly positive, well, it's not strictly positive down there. It's not strictly positive there. It is strictly positive here up to here. At this value of x equals 1, it's not defined. And at x equals 3, it's 0. So the first place where it's strictly positive is between between 1 and 3, but not at those endpoints, right? And then the next place where the gradient is positive is for everywhere above here. But again, be careful, it's not strictly positive here at 7 because the gradient's not defined there. So the other place here, we've got x greater than 7. The next question's asking, where is the gradient 0 and the graph is concave down? So it's a second derivative test we're looking for. So where's the gradient 0 and the second derivative is negative? Well, this is where it's 0. That's one place that it's 0. The second derivative in this bit here is going to be 0, so it's not there. It's just at x equals 3. And where is the function continuous but not differentiable? So this is the test of, do I have to take my pen off the page? So continuous but not differentiable. Well, here it's not differentiable, but it's not continuous. Here it's not continuous because there's a hole in the function, and here it's not. So this is the point that I'm after. Continuous but not differentiable is at x equals 5. So let's mark and see if I've missed anything out. You've got to be pretty nitpicky with how you go through these. So we've got 5, -3 and 1. Yep, those two places. 3, and look, I've made a mistake here. So that was really silly of me and really easy to do. So we're saying where is the x value where it's continuous and not differentiable? I've done something really stupid there, and I'm sure someone's going to tell me in the video. Here, it's not continuous, right? That was really, I should have not done that. It's not continuous here because there's a hole in the graph, right? So that is wrong, but I'm not going back and redoing the video because so far the dog has not woken up and started moaning. So it's not at 5, it's here, right? Continuous but not differentiable is at 7. Let's see, I still luckily would have got the merit mark. We have to get 3 out of any 5 of those correct. Hopefully you can see that actually this was pretty easy for merit once you got the hang of it, and so now it's usually going to be achieved. It's still a really good set of concepts to understand though, so I do like these questions. Right, 2017 paper, and then we're going to wrap it up. So here's the weird graph. Find the values of x that meet the following conditions, right? Where is the gradient 0? Well, it's 0 back here until we get up to there, and then it's going to be 0 again here, and that's about it, I think. So x strictly less than -2. The gradient's not defined here, so that's not a point, and then at x equals 2. Where is the function continuous but not differentiable? So here is one place. It's continuous. I did not have to lift my pen, but the gradient's different on both sides. So let's write that down before we forget. So -2. Here it's not continuous. Here it's not continuous. And here again, continuous but not differentiable. So x is 1. Next up, where is the function? Why is the eraser doing that? Where is the function not continuous? Right, it's not continuous here because there's a jump. That's what the little hole means. Not continuous here, but they are the only 2 places. So x equals -1 and 0. Where is the second derivative negative? So where is my gradient decreasing? Well, it's not through here because there my second derivative is 0. The gradient's not changing. And here the second derivative is 0 because the gradient's not changing. So it's in here. This is where the concavity, it's concave down. And it's not going to be defined there. So it's going to be for x is greater than 1. Right, what is the value of the function? The limit is the function is going to x equals -1. So here, if we go towards here, it's going to the same place from above and below. So the limit is 2, right? So f of -1 is equal to 1, but this limit is equal to 2. Let's mark it and see if I got anything wrong this time. Right, that one's right, that one's right. Okay, cool, I can still do a little bit of maths. Thanks for watching, and I'll do some more later, but hopefully that helps to start you off with these problems.